It's asking find the steady state current through the inductors. First, in the first diagram, you manage. Looking at the first diagram, write the equations. At steady state, we do replace inductor with a short circuit. So I'll directly come for with the current at steady state. We are discussing everything at t equal to infinity, not at any time t. So what is I1? Directly straight away, I think we can write it. I1 is equal to. Now, can you hear me?
Yes, sir.
The mic position was different. So what is I1? I1 is equal to E by R1. So what is the best way? So let's draw the equivalent circuit. The equivalent circuit will be where all inductor is there, short circuit. Where all inductor is there, short circuit. This R1, this R2. So how much of current will flow here? I1. Here current will be flowing is I2. So what is I1 from straight away from diagram? I1 is E1 by R. Sorry, E by R1. And what about I2? E by R2. These are the steady state currents at t equal to infinity. Let's come for here. So what I should do here, the inductors I'll replace with a short circuit. Then two short circuits, how to divide that current equally in both the short circuits. The current will divide. And they're ideal. These inductors are ideal. Ideal means no resistance. Only they allow self-inductance. Before replacing with, sorry, only told at t equal to infinity will replace with a short circuit. I will replace with two short circuits. You look at once. Let's write the current at any time t. Let's write some equation. We'll see what do we get. Let the current here be I. Then I'll write the loop equation plus C minus IR minus L di1 by dt equal to 0. Across the first inductor, across the second inductor, plus C minus IR. This is L1, no? L1, L2 di2 by dt. Equating these two, I'll end up L1 di1 by dt equal to L2 di2 by dt. dt I'll cancel out. L1 di1 is equal to L2 di2. Integrating. So what is the current? 0 to I1, I2. So L1 I1 is equal to L2 I2. And what is that I1 I2? Should be equal to, after long time also, where all that inductor is there, I'll replace short circuit. Let it be, no problem. This is a hypothetical problem because we never get inductor with ideal. I think you must able to understand just on paper. These I. So what is I is equal to I1 plus I2 from KCL. Then with this we'll get I1, I2. This will be substituting this equation here. I is equal to I1. This will be L1 I1 by L2. So I1 is equal to L2 I by L1 plus L2. Similarly, what is I2? I2 is equal to L1 I by L1 plus L2. I'll ask you what how much of energy present in each inductors. L1 I1 square by 2, L2 I2 square by 2. You can calculate also that energies at steady state. So what's wrong? You replace short circuit, then two short circuit wires. I'll write I by 2, I by 2. No, you can't do like that. That replacing short circuit is a method we have brought it. Try to understand. So don't try to generalize everything. So you only said short circuit I by 2. But look at the KVL or the concept what it tells. The currents in fact will be different. Making observation, I think uh, rather than just head bent on generalization, we must try to analyze once. So how do I come to know in exam? It's better to rather than that shortcut methods. It's better to stick onto the traditional method. What is the traditional method? Writing loop equation. If there is only one loop, one inductor is there straightforward. But when there are two inductors are there, no, it's better to think like this rather than straight away replacing short circuit work. But you did here. I think it's quite clear. Here you write equation like this. You can see that the current I1 is independent of L2. The current I2 is independent of L1 because this is one R1 L1 is there. This will be very troublesome for students only. So there's nothing called like a one general rule so that you can apply everywhere. So slightly open situation to situation, it will be different. So altogether, what is the basic like a idea of the or what is the basic general rule is write KVL, apply KCL, and analyze the problem. So you'll be on safer side.